This video is going to teach you how to make a box plot from the cumulative frequency curve. Again, this is a problem we did in class. Again, if you need a little extra help, this is here for you. And so what I have is a cumulative frequency curve, and the points on a box plot are the min, the lower quartile, the median, and the upper quartile, and then the max. So I'm gonna, if you notice here, we already have all those points marked. So it looks like the min, or excuse me, it looks like the min is 0. The lower quartile is 21, the median is 27, the upper quartile is 38, and the max is 60. So those are, that's my it's called my 5-number summary. And then all I gotta do is put them on a graph. And if you notice down here, there's a box around the interquartile range. So from 21 to 38, there's a box. You make a line at the median's 27, so somewhere in here. And then you stretch the whiskers out to the min and the max. And that divides the data into fourths. The thing that people often do is make every section the same length because they don't set a scale ahead of time. And so you need to set a scale ahead of time to make sure that you're doing all of the points the right distance. So if there's 100 values here, that means 25 are here, 25 are here, 25 are here, and 25 are here. So half of the data falls in this little box right here, or half of the data falls between these two, or half the data falls between these two. So it's evenly dispersed, and you can look at it. As long as you put it on a scale, you can look at it. We're going to keep going here. This is just kind of the summary of the 5 things. And you notice there's no scale written here, but you can see that they used a scale because the widths are not equal. If you get done with your box and whisker and every section is the same, you probably didn't use a scale. So you'll notice you just kind of make 5 slashes. And box around the middle ones. Notice how they labeled it really nice. So the interquartile range is from 8.5 to 16.5. So the interquartile range here is 25. Sometimes we can use this to estimate the average. If you're going to do that, you know that the average here is the midpoint. So the midpoint of 0 and 8.5 would be 4.25. The midpoint between these two would be 10.5. The midpoint here, it's a distance of 4, so 14.5. And the midpoint here, the distance between the two is 8.5, so half of that is 4.25. So 20.75 would be the midpoint. And since we don't know where the values are on the box and whisker, we're just looking at the averages for each of those. You could add those up and divide it by 4, and that would be your only way you could get much of a mean there. You must have a scale. That's been mentioned multiple times here. So it says draw a box plot First thing to do is order it. You can use sort A on your calculator to order it. Or if there's not very many numbers, you can sort them yourself. But I would enter them in a list and then use sort. The median is in the middle. In this case, we have an even number, so the median is between 8 and 8, which is just 8. And then the lower quartile is the middle of the bottom, so this would be 5.5. The upper quartile is the middle here, which is 9. And then I have my min is 4. My max is 12. So there's 1, 2, 3, 4, 5 points. I'm going from 4 to 12, so I need to make a scale. I think I can go by 2s. I could have made it a little bigger probably. Now you just plot those points. So there's the 4. 5 would be here, so 5.5 somewhere in there. 8. 9. And then reaches out to 12. So the whiskers go out to the edges. So you make a box around your middle 3, and then you reach your whiskers out. Again, if you have a scale and a ruler, it's a lot nicer. I think on the next slide I can show you what it looks like in a nice form. So they made a scale, put it on the scale. So some questions that somebody could ask you about this. Find the range and interquartile range. Remember that the range has to do with, relates more to the average. So the range is the biggest value minus the smallest value. So 12 minus 4, which is 8. And the inter means between. And that is the values from here to here. So 5.5 and 9. So 9 minus 5.5, which is 3.5. Find the percentage of data values less than 10. So less than 10, these are integer values, means that they are 9 or less. So we're talking about all these data values. Percentage of that, 25% of the data is in each little box. So there's 3 of the boxes, so 75% would be less than. Draw a box plot for the following. They're sorted. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 this time. So when I go to draw it, if you come in 5 on each side, then your median is 8. And I look at the bottom half, and the median is 4. Top half, median is 10. So this is the upper quartile, or Q3. This is the lower quartile, or Q1. Minimum is 3. Max is 15. So let's see what it looks like when we draw it. The box goes around the 4 to 10. The line goes in at the median, reaches down to 3 and all the way up to 15. So again, there's 25% of the data values are in each category. So like the bottom 25%, what you could do is say there's a lot of values that are really close together in that section. And there's a lot of values here, so the upper quartile has a bigger spread than the lower quartile, different conclusions like that. Find the range and interquartile range of the data. The range, highest minus lowest. Interquartile range comes from taking the two quartiles and subtracting them. Percentage of data value is greater than 7, so that would be 8 or more. That'd be 50% of the data values. And that's about it. Sometimes we do double box and whiskers to be able to compare things side by side. You can easily see like the interquartile range of the top graph is bigger than the interquartile range of the bottom graph. The overall range, it's pretty close in the overall range, but you can see side by side the data values.